All right, so this is 2007 question number 2. We do have a calculator for this. I'm assuming you've read the question. What we have so far is we have water going into the tank, which is F of T, and out of the tank, which is G of T. Our starting point is 5,000 gallons of water that we have. Our time frame looks like 0 to 7 hours. Let's see. Part A, how many gallons of water enter the tank during the time interval? All it's asking is for how much water enters the tank. All I care about is F of T. I don't care how much leaves the tank. I don't care how much was there to begin with. So for part A, I want to add up, that's an integral, all of the water entering the tank from 0 to 7 hours. I'm going to put this on my calculator. I'm going to integrate it on my calculator. And when I do that, I want to make sure I round my answer to the nearest gallon. So I'm going to get 8,264 gallons of water. So that's part A, very straightforward. Part B, I'm looking for the time intervals during which the amount of water in the tank is decreasing. This is actually not that bad. If you look at this graph, and I've kind of drawn some, I've sketched in a little bit. I labeled the point of intersections, and then I kind of draw this dotted line at 3. If I want to know when the water in the tank is decreasing, I want to know when is water leaving the tank, G of T, bigger or faster than the water is entering the tank. So if I look at this graph here, from 0 to 1.617, G of T is greater than F of T because it's higher on the graph. So therefore, water is leaving the tank faster than it's coming in. Therefore, the overall water level is decreasing. And then again, from 3 until 5.076, during that interval, G of T is higher than F of T. Therefore, water level is decreasing. So now I just have to write that out. So if I look at this, let's see here. Part B, I'm going to write down for my time interval 0 to 1.617, and then from 3 to 5.076. That's a decimal in there. And my explanation is simply that G of T, the rate at which water is leaving, is greater than F of T during these time intervals. Okay? Now, that's 4 points out of the 9 points that this question is worth. This is where they're going to get you as part C. What they want to know on part C is, at what time is the amount of water in the tank the greatest? That's a max. The amount is a max when the amount prime is 0 or D, N, E, and I have a sign change plus 2 minus. Now here's the big thing. I think about, well, how do I figure out how much water is in the tank at any given time? If I wanted to find the amount of water in the tank at any given time, I would do the initial 5,000 plus the integral of F of T minus G of T. I mean, because this is going to give me the original plus I'm going to add up all the water going in, and I'm going to subtract all the water going out. Now, if I take the derivative of all of this, the derivative of 5,000 is 0, and then the derivative of the integral is just going to leave me with F of T minus G of T. So when I look at this, the amount prime, that just means when is F of T minus G of T equal to 0 or DNE? Well, let's think about this. F minus G is equal to 0. So that's saying, when does F of T equal G of T? When are they the same? At the points of intersection, which have been given to us on our graph. So what I'm going to do is I'm going to set up a nice little number line here to try to figure out what's going on. And let's see, this is my F minus G number line. Closed interval 0 to 7. The points of intersection are 1.617 and 5.076. Now here's the other piece of this, which is kind of the kicker. When I look at this graph, I can see that something's going on at 3. After 3 hours, we have an open, we have a gap there, we have a puncture point. If you look at the piecewise function, when t is 3, that is not included in either one of these intervals. So there is something funky going on there. We have to take that into consideration. Now, if I'm looking at F minus G, looking at my graph, from 0 to 1.617, F minus G, that means a lower number minus a bigger number, that's going to be negative. And then from 1.617 to 3, F minus G, that's a bigger, higher on the graph, minus a lower number. It's going to be positive. and then this is negative and positive again, all based on my graph. Therefore, when I look at this, I can clearly see that my possible max is when t is 0, 3, or 7. One of those answers is when I have the most water in the tank. So now what I need to do is figure out, okay, well, how much water is actually in the tank at those different times? So that's what I have to do now. I have to test my points at 0, 3, 7. Well, here's the nice thing. The amount of water in the tank at 0 is 5,000. That's given, that's initial. Now the amount of water in the tank after 3 hours. Well, let's think. 5,000 plus the integral from 0 to 3 of the water going in minus the water going out. Now this is the trick. The water going out is a piecewise function. From 0 to 3, the water going out is 25. Let me double check that number. I'm sorry, it's 250. I knew something was off there. So this is what I need to do. I need to do 5,000 plus the integral of f of t minus 250. And when I do this, I get 5,127. So that's going to give me how much water is in the tank after 3 hours. Now what I need to do is find the amount of water in the tank after 7 hours. This is where it gets really tricky. If I look at this, I can't just change that upper limit to a 7 because this number changes. So what I'm going to do is I'm going to say, okay, this is how much water I have in the tank after 3 hours. So now I'm just going to add on to that the integral from 3 to 7 f of t minus 2,000, which is the rate at which water is leaving the tank from 3 to 7 hours. So that's my new rate for the out. So this is what I want to calculate now. And what I end up with is 5,127 minus 612, which I can already tell you is less than that. Therefore, this is what's giving me my final information. I have a max of 5,127 gallons after 3 hours. And that's your final answer to the question. My max amount, and that's my time frame. My justification was way up at the beginning when I wrote out my basic justification for a max. There you go.